Hello, my name is Alexander. I am an engineer working at VTM Group. Today I will demonstrate to you the functionality of our latest innovation, our brand new testing stand, Turbo Boost Test. The Turbo Boost test is specifically designed for the precise adjustment of variable geometry turbochargers, as well as for the thorough testing of the turbo boost of the compressor in a dynamic operational mode. When we install the turbocharger on the machine, we connect the oil drain, oil supply, speed sensor, air supply, inlet pressure turbocharger, air outlet, and turbocharger outlet pressure. We also connect the vacuum pressure. The machine is designed to test turbos both with pneumatic actuator and with electronic actuator by connecting our ATP 1000 device to the machine's computer. There is also a function to check the N75th valve. There's a set of cables like this. They plug into this one here, plug in the valve, plug in the connections, and we check the N75th valve. The machine has the following controls. We can see the oil pressure gauge, which is regulated right here with such a throttle. We also see the oil temperature indicator. The oil temperature can't be changed. It's set of 60 degrees and cannot be changed. There is a vacuum pressure gauge, which can be used during the test to monitor how the vacuum pressure changes. From the buttons, there are buttons Start Measurement, Stop Measurement, Oil Start, Oil Supply, and Oil Stop, and turn the oil heating on or off. You can plug in a keyboard. There's a special keyboard shelf and a shelf for the mouse. You can connect the keyboard and mouse using Bluetooth, so there won't be any wires. The system initiates, and initially, the indication menu emerges. This means all of these indicators must be illuminated in green. This indicates a connection with all the devices of the stand. Also here you can check the operation of the various buttons and modes of operation. The program has a function geometry and pressure checks. Next, you can adjust stop of the pneumatic turbocharger in dynamic mode. Checking the turbocharger geometry play. Inspection of valve N75th. Additionally, there are icons to upload the test plan while in geometry setup mode. Select the desired turbocharger, load, get test plan and engine characteristics, to which the turbocharger is being fitted. And there's a button to save the test plan. So when you've taken a measurement turbocharger, you can save your results and save the test plan. In the program, there are the following windows and control buttons. There is a data tab. In this tab, the turbocharger number is necessarily indicated. The turbocharger model and serial number, you can leave it blank. You enter the characteristics of the engine and turbocharger on the car on which the turbocharger is installed. There is also a P-out window, a turbo boost chart, a graph showing the output pressure from the turbocharger. P and pressure graph for the turbocharger. Test 1, Test 2, Test 3, Test 4 tabs, and in them are pads like this. This block of buttons is necessary for visual objective control of the correctness of data reading from the turbocharger. We also have a button when we start the program. There's a warm-up button, heating that is, when we have connected the turbocharger, turned on the oil supply. We press the warm-up button, and if you haven't turned it on, you get a window that says you have to turn it on, and it starts warming up. At this time, you can define data turbocharger and engine data, fill it in. Or you can do it later, when all the necessary measurements have been taken. Button start starts the measurement. Stop button. Warm-up cutoff button. The button to toggle the mode to switch between turbo boost test mode or just geometry adjustment. Button to toggle pneumatic or electric actuator. There's a button to print out test plans of the measurements performed. There's a button to clear previous graphs, so when you're taking several measurements in a row to clear previous results, you need this button. Start window button, the settings button, and the start window button window. In starter window mode, we can control the vacuum. So we have the ability to connect a necessary turbocharger or N75 valves and manage the vacuum system effectively. The bench is connected to a 380-volt main supply up to a maximum of 5 kilowatts. No further connections are required to the machine. Connection of the turbocharger. The turbocharger is connected by means of special adapters like this. These are either these silicone rubber sleeves or a metal universal adapter. There is also a set of other adapters. Let's imagine that we have a turbocharger after a repair that's upset. That is, the stop here is unscrewed. The lock nut is not clamped. We've unscrewed the stop. We do not have a plan for turbo tests. The first thing we do is we warm it up. We've got the oil on. Geometry tuning mode is set. In this case, what can we see after the measurement? Well, this blue line shows at which setting the turbocharger is operating in maximum efficiency mode. This is the boost characteristic. This is the back pressure characteristic by geometry. In this case, we see that when adjusting the back pressure, if you look at the graph, somewhere around 260, 270 millibars of back pressure on the turbocharger, we're going to get the turbocharger in maximum efficiency mode. So, in order to set the turbocharger up properly, in this case, we need to set the turbocharger stop so that the back pressure is in the range of 260, 270 millibars. That's what we're going to do. To do that, we're going to go to the tab of the Geometry Stop online settings and launch. In the appropriate windows, we can also see the back pressure value, turbo boost value. The adjustment is done. Let's go into the customization mode geometry and do the next run. The turbine is already warm, so you can skip the warm-up mode now. The vacuum drops to 0.7, then the measurement starts. As a result of the tuning, we can see that in terms of back pressure, we've got it set to somewhere around 260, 270 millibars. So it was like this, now it's like this. Here was a little bit of a hump here. But eventually we got the turbocharger in maximum performance mode. So you can see that the turbocharger was blowing up at 75 millibars. It stayed that way, and the back pressure dropped to 260 millibars. We have installed the turbocharger. The initial step, naturally, is to simply run the program for the very first time, install the turbocharger, and then we want to verify it. We turn on the oil supply. The oil is already on, and we turn on the warm-up mode. You can close the lid so that there's less noise. In the warm-up mode, we observe the boost pressure graph displayed in real time. This is necessary to understand that the turbocharger has warmed up. When this line that's coming up, half of the field will be, if the turbocharger is flat, it means that the turbocharger has warmed up. If the turbocharger is warmed up, so you've taken previous measurements, and you're taking them in a subsequent tune-up, you can almost literally turn the warm-up mode off after 5 or 10 seconds, or turn it off right away. We can see that as soon as we started, there are jumps on the graph. So this indicates that the turbocharger is warming up. We can see that the line is more or less flat. We can wait and make sure that the turbocharger has really warmed up. You can turn the warm-up mode off by pressing the button to turn the warm-up off. Right now, we're in a mode geometry check. Now we're going to be getting data, the turbocharger geometry setting. We can take a look at the vacuum gauge to see the pressure. When the pressure falls below minus 0.7 bar, that's when the measurement mode starts. Also, we have a default temperature of 60 degrees, and the oil pressure should be 3 bar with a slight variation. The measurement of the turbocharger geometry setting is complete, and in the corresponding windows of the turbocharger's boost pressure and intake pressure, you can see the corresponding graphs. We have not entered turbocharger number. We can look for a test plan, if there is one. In this case, we've got this turbocharger, 709-838-5, in the sample folder that is always on disk C. According to what we're seeing, we can say that the turbocharger somewhat configured, but it can be further adjusted more. because we've got the boost pressure pretty much in line with the test plan, but the geometry back pressure is a little bit higher than the test plan. So that's something we can fix. In order to tune the geometry of a turbocharger with a pneumatic actuator, there is a mode to adjust the geometry online. I mean, you can see here the values that are on the graph. Here's 195. If we look over here, here's our 195. This is the stop, the variable geometry, the adjustment of the stop. As we look at it, we can see that the setting is off a little bit, so it can be fine-tuned. We toggle the vacuum on and off to confirm the settings. The adjustment is done. Next, we check our setting on the graphs. Start it up. The heating can be turned off. In this case, we see that we have adjusted the back pressure of the turbocharger geometry according to the test plan. But as a result of our actions, we reduced back pressure. The turbocharger rotor is spinning a little bit less. So that tells me that the turbocharger on this test plan is set to limit the maximum boost of the turbocharger. Based on these conclusions, and based on the goals that were set when the machine was designed, the information in these two graphs, it is possible to judge the efficiency of the turbocharger. So we can use these two graphs, can tune the turbocharger in the maximum turbocharger performance mode. Due to the fact that turbochargers of the same model can be fitted to different cars with different engines. In some cases, it may be necessary to adjust the turbocharger's output by tuning the turbocharger itself. Therefore, in some cases, the turbo boost may be intentionally limited by the turbocharger, and in some cases, unlimited. The first time we checked only the variable geometry setting, and the setting was in geometry. There is also turbocharger tuning in conjunction with the geometry tuning check. Now we're going to check the geometry setting and turbocharge the compressor at the same time. Press start. We're looking at the warm-up graph. We can see how the turbocharger is warming up. That's positive growth. You can clearly see a line, so you can turn off the heating now. The warm-up mode can be turned off. The measurement is finished. We downloaded the test plan in advance. From the final graph, we can see that this turbocharger can deliver more than 154 horsepower. You can pick it up. See how much power the turbocharger can deliver. 74. You can still find it. About 180 of horsepower that this turbocharger can deliver. We're looking at the geometry settings on the test plan. The graphs are the same. We've installed a turbocharger with an electronic actuator. We've wired it up through an instrument, the ATP-1000, to our machine. And we're going to check the tuning of this turbocharger. We can observe the graphs of back pressure geometry and the turbocharger boost graphs. It's a graph of turbocharger performance. We check the backlash of the turbocharger geometry. Here's our tab. Press Start. We can see that the backlash of the turbocharger geometry is minimal, so it's a fully functioning geometry. If the backlash is greater than about 15 to 20%, this is a geometry that needs to be replaced. So checking the N75th valve. In order to check the N75th valve, you have to plug the vacuum connection with any kind of plug. Vacuum in, vacuum out, vacuum out. Valve number, start. Again must be plugged. This valve in good working order. On the graph, we can see that this valve is faulty. Its characteristic is markedly different from the reference. We can print out a report of all measurements and gauges taken. We can specify the customer, organization, operator. We can see our report. There will be a graph of performance. We have not done this now. A graph of geometry tuning. The turbocharger backlash. Geometry of the turbocharger. N75th valve check last. That's the report.